Okay, so yes, good evening once again, guys. Today we're actually going to be talking about classes and inheritance. Yeah, so we're looking at classes and inheritance today. I want to believe you're ready for the class, so let's just dive straight into it. So I'm going to be sharing my screen right about now. Yeah. Okay. Yeah, so confirm you can see my screen by either raising your hand or dropping a message on the chat. Okay, thank you. Thank you very much. Thank you very much. Yeah, so we're going to be looking at classes and inheritance. Yeah, in Kotlin. So that's going to be the topic for today. Yeah, classes and inheritance in Kotlin. Okay, so a few things we're going to be talking about today. Okay, let's just see if we can do something like a goal for today's class. So it's going to be a long one though, but we'll try as much as possible to see how much we can cover, in this first aspect. So we're talking about class hierarchy. Okay. I'm talking about class hierarchy, and then we look at the some various types of classes. Think about especially the abstract class. Well, let me just put that here. Abstract class. Also talk about inheritance. Yeah. So I think I think this basically that's I think I'll just update it as we move on. Okay. So yeah. So what now? One of the things that humans actually love to do is to classify, themselves, items, and certain things. We like to classify things so it's easy to identify them. So and then we make these classifications with respect to similar properties that these items actually have. Okay, similar properties, similar behaviors. So we use these yardsticks. Okay, we use these things to separate things, to classify stuff into groups. Okay, and also we, of course, when classifying them, we also form what we call a hierarchy. Okay, basically this before this before that, and the likes. Okay, so a typical example, and that's the example we're actually going to be using. Okay, I'll just use this, but we'll use something else to really write a code. Okay, so implement it in code. Now, a category like vegetables. Okay, vegetables. Now, we know that for vegetables, we have specific type of vegetables like legumes. Legumes are a specific type of vegetable. Okay, and then within legumes, okay, we can actually have more specific types like beans, soya beans, peas, and the likes. Okay, so this is more like this kind of like an example of how we classify stuff, and then how we get to also put them in hierarchy. Okay, so we can represent these items. Okay, we can represent these items, one after the other based on certain properties. We decide that okay, this one should come first. This one should be like a higher one. This one should be lower and stuff like that. Just like you have the local government chairman, you have the and the likes. You have the governor, you have the president. They are just hierarchy of several offices. Okay, so that's basically that. So let's see how can we actually represent this now using vegetable as an instance. Okay, using vegetable. Okay, now a vegetable could be, now since it's more like the highest category. Okay, since it's like just like you have the president of a country, that's kind of like the number one citizen. Every other person is, you choose your number. Okay, so he's the number one citizen. So it's more like the main guy. Every other thing, every other office, kind of flows from that, down, when you want to break it down. So using vegetable, for an instance, we can now call that the parent class. Okay, either we call it the parent class or we call it a super class. Okay, that is what it is going to actually be, because now we're trying to just see how to represent this whole relationship, this whole class and hierarchy, how to present that, okay, in code. So assuming vegetable now is a class in Kotlin, now we can have legume, okay, as a subclass. So we can either call it a subclass or we call it a child class, because it is, it is below, it's, under the vegetable. So the legume becomes a child or a subclass of the vegetable class. So what this means is that the legume will, it has all the properties, all the methods of the vegetable class. Okay, remember we talked about objects, we talked about classes and like, so it has all the properties, it has all the methods of the vegetable class, okay? So what that just also means is that legume is inheriting these properties from the vegetable. Okay, we'll get to really understand this more when we start actually writing it out, in actual code. Okay, so vegetable becomes the parent class, legume becomes the subclass. Now we can still expand this more. Okay, under legume we could have the bean, we could have the peas. So this one, so let me say this is the child class of vegetable. So these beans and peas, okay, they are now the subclass, or we can just say subclasses, or we can actually just call them children. And what are they children of? They're children of, or subclasses of legume, because they are below legume. Sorry about that. Okay. Yes, of the legume class. Okay, so let's just put out some terminologies now. Okay, a class hierarchy is basically an arrangement, okay, where classes are organized in a hierarchy of parents and children. Just like you have an organizational hierarchy. CEO, general manager, technical director, and likes, and all those departments. Okay, so so a class hierarchy is an arrangement where classes are organized in a hierarchy of parents and children. Okay, now another thing too. So that's about class hierarchy. Okay, now when we say subclass or child class, what do we mean? Okay, so child class or subclass is it's any class that is below another class in the hierarchy. So any class that is below another class is the child class of that one. Okay, now we'll talk about parent class. Okay, parent class or super class, or it is also sometimes called base class. Okay, so this is any class that has one or more child classes. Any class with one or more child classes. Okay, now there's also what we call root or top level class. Okay, so the root or top level class is basically the class that is at the top of the class hierarchy, or at the root, that top or root of the class hierarchy. And then the last thing the last terminology here is this inheritance, very important. So of course we know what inheritance is in the actual sense. Okay, so it's just to bring that knowledge now and implement it in this particular scope. Now, so when a child class inherits all the properties and methods of its parent class, that's just what inheritance is. And the interesting thing about inheritance is that it helps you to share and reuse code. And of course, that makes your programs actually easy to understand and maintain. So inheritance, just like, so inheritance is just, where a child class includes or inherits the properties and methods of of its parent class. Okay, so let's look at inheritance in Android. Okay, now of course, while you can actually write your Kotlin code without using classes, yes, you can. Okay, you can actually write your Kotlin code without using classes. Okay, but there are many parts of Android. Okay, there are many parts. Okay, many parts of Android are actually provided in form of classes. Okay, in form of classes. And the reason is because it kind of helps, it just makes the work easy. So you don't have to rewrite, a lot of code. So now the fact that these stuffs are provided to you in form of classes, okay, including activities. Activities is a class. View is a class. Your text view, buttons, those are classes. View groups, constraint layouts, linear layouts, relative layouts. We get to use some of these layouts. These are what? Classes. Okay, so it's very good to understand class hierarchy. It's very, very important because it helps you to take advantage of some of these inbuilt classes that Android actually provides. The Android framework actually provides. Okay, now let me give us an example with respect to view. Now, for example, there's a view class in Android. Okay, there is a view class in Android. So let me do this. You have a view class. Now, this view class is the parent class. Okay, now it actually has subclasses. Now, a typical example of a subclass is the text view that you have used. So it is below it. So let me just probably give an extra space. So the text view is the child class. So you can either call it the child class or you call it the subclass, okay? So it is a child view, the child class, subclass of the view. So that means it is a subclass of the parent class, and the parent class is actually what? The view class. Okay, and then we have under the text view, we have some other child views embedded in it also, and which are, we have the edit text. You get to use it when you want to the text for imputing, when you want to impute this data. Okay, and then the button. So this button and edit text, they are children, or you can say subclasses of the text view. The text view is a child, or you can say a subclass of the parent, and at the same time, it is the parent or superclass of the edit text and the button. Because remember, we said that the parent, any class with one or more child classes, you can call it a parent class, you can call it a superclass, or you can call it a base class. So because in as much as this text view is a child class, is a subclass, it is also a superclass to these ones because it has a child class, it has children. It has one or more child classes. Okay, so at any point you have a question, okay, of course, just raise your hand or drop it on the chat. Okay, so so that's actually that. Okay, so one of the reasons this is actually very interesting and important is because now, instead of having to copy and paste all the logic of the view class and the text view classes into the edit text class, the edit text can just subclass the text view just like it has now, okay, which in turn is a subclass of the word view. So that means the code in our edit text class can focus specifically on what makes that component, that is the UI component. The edit text is a component, the UI component. What makes it different from other views? Now, of course, now a typical example is when we say it gets to use, it can actually use focus on what it is. Now, this is inheritance. If your dad leaves you a company, okay, your dad leaves you a company, you inherit the company from your dad. Now, even if he's alive and he hands it over to you, or he's dead, whichever the case may be, but if it has been handed to you, you're inheriting that property. Now, you have the liberty to make adjustments into how it suits you. Now, you do not need to. So imagine if your dad has a company of over 20 years, and as he's inheriting it to you, as you're inheriting, you now have to rewrite everything, every mission statement, you have to rewrite everything to actually, to actually start using that business name. Or you have to rewrite every functionality, every department, you have to rewrite everything. Now it's going to be burdensome. So, and then maybe your own son have to actually inherit your property, company has to also rewrite. No. So in inheritance, there are certain things that are kept, there are certain structures, properties, methods, functions that are just kept there, that when you inherit, you can now, you're flexible with it. You can use it the way you actually want. So a typical example is that as a company, there should be hierarchy. Okay, you can have a finance department. Okay, you can have the technical department. You can have the HR. Now, there is already a HR department. So of course, if you're inheriting that company, you don't need to start up a new HR department. You can just modify to suit you and probably how you want to take that company forward. So that's the beautiful thing about inheritance. You don't have to start from scratch. You don't have to always, build everything again. You can just inherit from what's there and modify to suit what you actually want. So that's actually just the concept of what inheritance. Okay, now, so let's actually apply that in code. Okay, let's apply that in code. But to just backtrack and kind of do a summary, a very quick summary. A typical example of a class could be a car. Okay, I'm just going to backtrack a bit. Now, a car is a class. Now, every car has certain properties that no matter what, no matter the kind of car, okay, no matter the kind of car that you have, it should have that property. Now, I could decide, a typical example is that every car has a color, whether you like it or not. Every car has a color. So a color becomes a property. Every car has, who can help me? What's one thing that's common with every car? Properties now, I've talked about color. Every car has speed.
Wheels.
Plate numbers.
Okay. So these are all properties of a car that no matter the car you want to build, no matter the make, it should have these properties. Okay. Now, what other there are methods that, okay, Zed said engine, yes, good. So there are methods that every car has. Now, when I say method, there are functions. A typical function is that every car can drive. Let me just use that. You understand? That's a function. Every car, of course, you will not build a car that cannot move. So maybe I can just say can move, but let's just say can drive. Okay. Every car, what other method, what other function?
Uses fuel.
So yeah, fuel. So of course, fuel now would be relative. It could be whatever, but we're going to use fuel in the aspect of what fuel literally is, not the type. Okay.
Okay.
So so every car. Well, that's good. That's actually a property, Sha. It's great. It's a property.
Okay.
The property. It's a property. So why I said there's a difference between properties and methods. Methods require instructions to perform that. That's why for you to be able to drive every car, for you to drive, at least there are certain things, instructions. You need to probably start it. Maybe you need to check the oil gauge and stuff like that. But color is just color. You understand? You don't need to calculate color. You don't need some instructions to do that. So let's just do that. So we'll keep moving, Sha. So yeah, so these are properties. So when you want to, so every car has this property by default. So if Z on its own now decides that, okay, I want to create a car, I want to build a car. Okay, Z doesn't need to start thinking of, I want to build a car now, what properties should my car have? No, it doesn't, no, it shouldn't be. Because by default already, there are properties that cars have by default. What Z will be thinking is, okay, I want to build my own car. What color should I use? Because color already is a property of a car. So now you're thinking, okay, what should the color be for my own car? What speed do I want my car to have? Should it be 100 kilometers per hour? Should it be 200 kilometers per hour? What wheels do I want in my own car? Okay, how should my plate number be? Should it be in front? Should it be behind? Should it even be by the side? Not even thought about that. Okay, should it be by the side? What kind of fuel? Do I want to build a car that's going to use water? Or do I want to use electricity or stuff like that? So he doesn't need to start creating properties. No, he just reuses it. Now, the fact that in reusing these properties, the fact that you're just thinking of color. Because why are you thinking of car color? Because by default already, cars have what? Color. So it's already a property. All you're thinking of is what color should it be? You're not thinking of color as a property. No, you're thinking of color as something you just want to choose what it should be. Okay, so that's just to further portray that. Now, we've talked about classes. So I want to introduce a type of class, which is the abstract class. Okay, because we'll use this to explain inheritance. Okay, let's now write some code. Now, any class can be the base class. I'm going to talk about base class, we're talking about parent class. So any class can be the parent class of a class hierarchy, any class at all. Now, but an abstract class, so let's go. An abstract class is a class that cannot be instantiated because it is not fully implemented. I'll take that again. An abstract class is a class that cannot be instantiated because it is not fully implemented. So what do I mean? What I mean is that you cannot create an object of an abstract class. Just like we created object of classes, no, you can't create an object of an abstract class, and I'll show you. It will try an error. You cannot, because it has not been fully implemented. So you can just think of an abstract class as a sketch. Okay, so your sketch just has ideas, and plans for something, but it's not enough if there's not enough information to actually build it. Now, a typical example is your plan, building plan. Yeah, there are information, but your building plan does not tell you, that's a sketch. Doesn't tell you the cement to use. It doesn't tell you the materials, if you should use gravel or that. It doesn't tell you the color of your house. It's just a building plan. It gives you the structure. So we actually use abstract classes to create a blueprint. And when I say blueprint, it means a class. So to create a blueprint, which you can use to build an actual object. Okay. Now, one of the very important benefits of creating a superclass, okay, is so that it contains the properties and functions that are common to all its subclasses. So text view does not, assuming a view for every view, every view should have color. Text view should not have to create a color property. No, it should just call the property. Okay, it should just call it. Edit text does not have to now start writing code to define a color variable. No, it should just reuse that color property. Okay, so if the values of all of properties and implementation of functions are not known, we now make the class what? Abstract. So basically what I'm saying is, when creating an abstract class, you're not really implementing it. Your functions, your properties, you're not implementing it. No, you're just basically what you're saying is just, so think of it as you just bring a bucket and you're not storing anything inside. Remember when we were creating a variable, declaring and initializing. So you're just creating a variable, but you're not storing anything. You want to leave the storing to whoever is going to inherit. So basically what I'm saying, I just have 5 buckets. I'm not going to put anything inside the bucket. I'll leave whoever wants the bucket, come take the bucket and use it to put whatever you want. That is the concept of abstract classes. Okay, so how do we declare an abstract class? We just do it using the keyword abstract. Okay, so for the purpose of this class, we're going to be creating a class called, so we're going to be using houses. Okay, so I'm going to call it dwelling. So this is how you create an abstract class. You use the keyword abstract. Okay, and then the name of the class. So abstract and say class, the name of the class. So we're going to say dwelling. So that's going to be the name of our class. Put our parentheses and then, so this is how you declare an abstract class. Okay, this is how you create or declare an abstract what? Class. Okay, so so what we're now going to do, remember we said that the abstract class, it doesn't contain implementation. Okay, it doesn't contain implementation. It just contains the properties and functions that are going to be common to any class that wants to actually make use of it. Okay, so let's define some properties. Now, for every dwelling, okay, maybe let me use house. Let me use the word house. Okay, let me use the word house so it can be relatable. Okay, so for every house, that has to be built, okay, or that will be built or has been built, there are certain properties that are common. Okay, so let's define some things that are true for every house. That is every house. There are some certain things that it must have. Okay, even though it will be different, there's a different implementation in other houses, but every house, in other types of houses, but every house must have that. So one thing that is common in building a house is the building material. No matter the house you want to build, there must be a building material. So we're going to create a property, a variable called building material. It's going to be of type what? String. Okay, so that is a property. That is one common thing that every house has. When you want to build a house, there's a building material you need. It could be sand for this one, it could be straws, it could be stone, it could be whatever. Okay, so let me do something. I'm going to run this and then you see something. So you see we have an error here. When we created this, it says property. So the fact that you see it sees this as a property, it doesn't see it as a variable. So it says property must be initialized or made abstract. Remember when I taught you declaring of variables, this is how you declare a variable. Declaring a variable is just you saying, okay, I brought a bucket and this bucket you should only put this kind of things in this bucket. Okay, that's declaring a variable, where you declare the variable name and then the type of data that should be stored. So, but you have to initialize it. So here he's saying that, look, you have to, this property, you must initialize it. But if you don't want to initialize it, that means if you don't want to, initialize it means you're giving it a value. So, but if you do not want to give it a value, then make it abstract. Making it abstract now means that anyone who wants to use it will give it the value that it wants. That's just what that means. So once I'll just add an abstract keyword here. And when I run this, there's no error. It means we are fine. It means all things are working. Okay, so let's move on. Now let's try to make an instance of this class. So so apologies, yeah, our class is not supposed to be the main function, so take that out of there. Okay, good. So let's try to, just like we created objects of a class, let's try to do that. So let me say val house. So I'm going to use small letter. So small letter is the variable, capital letter is the class. So this is how we usually create an object like this. Okay, so let's run this, and then you see an error. Cannot create an instance of an abstract class, meaning it cannot create an object of an abstract class. So take note of that. Okay, take note of that. So let's take this out and then let's move on. So let's add some more properties. Now, every house that you will build, okay, another property is that it will have is capacity. Capacity in the sense that there is a number of persons that should, that a house can be able to contain or should contain. Okay, so let's say, of course, we have to use abstract now because we are just defining properties. Abstract val, I'm going to say capacity. And this capacity, since capacity is going to be of type int because it's number, 20, 21 is a number, so integer data type. Because all houses have capacity, it does not change. Okay, it just modifies. Some houses can contain 2 persons, some 5, some it's advised it should just be less than 2 or what or so. Okay, so let's move on. Now, another property we'll add is number of residents. Now, when you want to rent a self-contained, now by default it is assumed that a self-contained should be for 1 person or maybe 2. But when you have like 4 persons staying in a self-contained, of course, it's not really ideal. Okay, especially when you're looking at comfortability. Okay, so that's what we'll talk about capacity. So when you build, for some of us who will go further in life to become landlords, so when you want to build a self-contained, you have an idea of the number of persons that should be in that house. Okay, self-contained, or if it's a 1 room, of course, it's just 1 person. Okay, so when you're trying the toilet, it's okay, maybe the width of this toilet, and it's just 1 person now, so let it just cover this space. Okay, so there's what we call a capacity. So, but at the same time, every house has another property, which we're going to call number of residents. That is the number of persons in the place. So in every house, there's always a number of persons that are staying there. Is that 1 person is staying in the house, or 2 persons are there, or 3 or 4? So that is a constant thing of no matter the house that it is, there's always that property called number of residents. Okay. So, but this one, we're going to make that property a private property, and I'm going to make that to show you that we can. I'm going to make it do this here. Let's say residents, and this is going to be of type int. Now, the reason I'm putting this here, I'm making it private. Okay. Now, putting it here, I want a situation whereby when you're, when you want to now make use of this class, you must tell me how many persons is going to be in that house. That's basically because, of course, you know that when you want to create an object of this class, you must pass in this value. Just like we did when we had the dice class, we had to put 6, else you have an error. You have to tell it the number of sides. So here, you have to tell me the number of residents, okay, you have in mind before you go out to start building the house. Okay, so that's what this particular property is for. So let me just push this down. I hope I've not sent. Okay, to have more space. Okay, so that's that. So it's marked private. Okay, now private is what we call private. That's keyword a visibility modifier. Okay, we call it a visibility modifier. Okay, yeah, so let's continue. So the private is a keyword, okay, and we call it, it's called a visibility word modifier in Kotlin. It means that this resident property is only visible to and can be used inside this class. Okay, you cannot access it from anywhere else in the program, in your code, in your program. Okay, so you can actually mark properties and methods with this keyword. So if you don't use it, otherwise, okay, when you don't actually put a visibility modifier, the default is that it is public. Okay, so there are other visibility modifiers like protected and the likes. We'll talk about them as we move on. Now, now we have added properties. Now let's add some methods, some functions. Okay, now okay, sorry, just 1, 2, 3. That's fine. Okay, yeah. So let's add something else. Now, when we have capacity, and then we have number of residents. Capacity means this building can take 5 persons. Number of residents means that, okay, well, since the house has a capacity of taking 5 persons, but there are just 2 persons there. Okay, so as we have defined this now, we can actually create a function too. That function is going to let us know if there is room for more persons to join that room, that house. Now, what am I saying? If you look at it like, assuming you have let's say a 3-bedroom, okay, and then you're already staying with someone. Now, if maybe your friend has an issue with house issues and the person is like, well, I can't pay rent, my landlord is telling me to leave. Now, how do you know that there is space in your place? How do you know there's room for that person? You check the capacity of your house as against the number of persons that are already there. So there's a calculation already going on there. There's that calculation. So from that calculation, you can now say, okay, I think there's space, come. But when you now think, I'm in a 3-bedroom and already I have like 5 persons that won't squat in with me. Guy, I don't know. Or you try, why not reach out to so person? You have already made that calculation. You have checked the capacity of your bill, you've seen the space already as against the number of persons that are already staying with you. And from that calculation, you're able to know that there's no vex, there's no room for you. Not because I don't want you to stay, but it's going to be too crowded. Why not try Z? Z is staying in a 2-bedroom. He's the only one. Reach out to him. So there's a calculation. So because there's going to be a calculation there and some instructions. So that's going to be a function. So we can create a function that has room. And then this function, we want it to, this function is going to return a Boolean. Now, returning a Boolean means to return true or false, because of course, that's what it actually returns. When you check my house, 3-bedroom, number of persons, 5. You understand? Is there space? Is either yes or no, true or false. That's the result of that calculation. Okay, so that's why our function is going to return a Boolean. So that is the function. And what do we do with this function? We are going to return the value of when the residence, okay, is less than the capacity. So that's what we want to return. We want to return the value that we get when we check, because of course, if you're in a 3-bedroom and you're just the only person staying there, if your friend is having house issues, okay, someone very close to you, it's 3-bedroom now, of course, there's space. You can bring him. That means it's just you versus the capacity of the house. So that's what we'll check. That's what we need to check to be able to know if there is room. And the result of that is going to give us a Boolean. So it's going to be true or false. So a typical example, you can actually just do the calculation. If the capacity is 10 and the residence is 10, is there room? You can just answer with the chat on the chat. If the capacity is 10 and the residence is 10, what will this function return? A true or a false? You can reply on the chat or you can unmute yourself. Z said was false, and that's true. There's no room because Capacity is 10, residence is 10. 10 is not less than 10. Okay, so it returns a false. Now, if the capacity is 10, residence is 8. Is 8 less than 10? Yes, true. That means there's room. If capacity is 10, residence is 15. Is 15 less than the capacity? No. That means it's a what? False. It's a return a false. Okay, so that's what function. And of course, for every class, you can check this for every house, you can check this. You can check this for this is a method that runs through all classes, okay? All houses rather. Okay. So let's run this code to be sure that we don't have any error anywhere. Okay, so everything is fine. Everything is fine. So we have just created a class. Now let's look at inheritance, where we talk about abstract classes. Let's now talk about, subclasses rather. Okay, subclasses. Okay, so sorry, just a second. Okay. Okay, so yeah, let's head back. Let's go back to where we were. Okay, so someone said, what if capacity is equal to residence? It's still false, now it's full, so there's no room. Okay, it's still false because there's no room. Okay, so let's create subclasses. Now, we are creating subclasses so that they can, inherit the abstract class. They can inherit the house class. Okay, so that's why we're creating subclasses. Okay, so let's create some subclasses now. So first one, of course, is going to be outside this one. So let's look at a square cabin class. So I'm just going to say class square cabin. Okay, so how do we now, inherit this house class? How do we inherit this one? How do we get to now indicate that this square cabin is going to extend, is related to this one house? How do we indicate that? How do we indicate that this square cabin is going to, get this property, is going to inherit this house class? Okay, so to indicate this inheritance, we're going to use a colon. We use a colon just after the class name, and then next thing is going to be followed by a call to initialize the parent house class. Okay, what do I mean? So a call to the house class. So that is actually what that. Now, with this, now let's run this and then let's see. Yes, of course, we will have an error. First things first, said class square cabin is not abstract and it does not implement the abstract base class and Now, basically what is, it does not, we have not implemented these other abstract properties. Okay, but that's not even the one I want to point out first. First things first, you can look at this one, no value passed for parameter residence. Means that that shows that since we want to inherit this, there is already a parameter, so we must pass it. So since we're extending this superclass, okay, we must pass in that parameter, and let's say, and the parameter is number of residents. So let's say the number of residents is 2. Okay, let's say the number of residents is 2. Okay, So that's actually that. So let's see if that takes out the error. Okay, so that takes out that other was error. Okay, so now the next thing is when you're now we need to make our program flexible and basically allow for a variable number of residents for our square cabin. Okay, because right now what we just done, we just created a square cabin class, and then what if we want to also, we need to, since the house class, okay, the base class has that residence. For you to actually build a house, you need to tell us the number of residents. Also, for you to build a square cabin, we should also know the number of residents also. So there should be that flexibility, okay, for number of residents for the square cabin, okay? So basically what we'll just do, we'll now make residents a parameter in our square cabin class, okay? So basically this is just what we will do. I'm just going to say residents. So it means that when I'm creating this one, I have to pass in the residence of type integer, which is a number of residents. So with that, I don't need to put 2 here again. I can just call residents, and this particular residence is this young man here. So of course this will have a number. So I'm just passing whatever number that's going to be put in here. I'm just passing it here directly. Okay, so this is just to allow for flexibility. Okay. So let me just note a few things, okay? Because a lot of things happen under the hood with some of these class definitions. Now, if you look at the class header, you see, you can see class, square cabin, and the whole of this, right? Now, this is just a short form of saying this: class, square cabin, constructor, residence. This is just a short form of writing this. Now, I know some of us will ask, what is a constructor? Now, the constructor is called when you create an object instance from a class. That's when a constructor is called. Constructor is called when you create an object instance from a class. A constructor is called. Right. So, for example, when we call, let's say, square cabin, and then we pass 4, the constructor of the square cabin is called to initialize that instance, that object instance with the 4 residents, that 4 residents instance, the residence instance that has a 4. When you put in a 3, it is it initializes that instance to have that 3. So basically, the constructor helps, it builds your instance from all the information in the class. That's what a constructor does. It builds your instance, that's your object. It builds your object from all the information in the class, including arguments, parameters that you pass. So when a class inherits properties and functions from a parent, the constructor calls the constructor of the parent class. So the square cabin constructor will call the constructor of this house class, okay, so that it can finish initializing the object instance. Okay, so just note that, okay. Now, but we still have this error that we need to take out, which is this: class square cabin is not abstract, and it does not implement abstract base class member. This abstract base class member. And what is the member? The member is this. You can see we only did abstract var building material of type string, which is defined, but you can see public here because we didn't put private. So by default, it is public. So when you declare abstract functions and variables, okay, what you're basically saying is that you're like promising that you will give them values and implementations later. So when we declared this, we are just saying that, okay, look, you know what, later, we are promised to look, before, when we are creating an instance, when we want to inherit, we'll give you a value. So for now, just be abstract. So now that we have actually created a subclass, we have to now fulfill our promise. Okay. So it just means that, like, for a variable, it means that any subclass of that abstract class needs to give it a value. So square cabin needs to give building material a value. Square cabin needs to give capacity a value. Okay. Okay. So this is what we're going to do. So for this one, let's now give it some value. So I'm going to say, so to actually give a variable that is to give this abstract variable, to give it a value, we have to override it. Okay, because in our house class, we defined an abstract variable called building material. Now, the square cabin is a subclass of the house, so it must provide a value. So we use this keyword override to indicate that this property was defined in a parent class, and we are now overriding it in the class. So it's just basically inheritance. So we have given your company has been given to you. So to use it, you have to override what was there. Of course, you're now the one in charge, so you can make changes. So how do we do that? So I'll say override. You can see that override val building material. So this is where we fulfill our promise, and then we now give it a value. So since it's of type string, so the building material for this square cabin will be wood. The next one is the capacity. So override val capacity. And then capacity is an integer data type. So let's say the capacity of this house is 5. So let's run this and see if that error goes out. Okay, so that goes out. That actually what goes out. So we are good. So we are good to go. So let's now test that this works. So to test this, I'm now going to go to my main function and create an instance of the square cabin. Now I can create an instance of this square cabin because now it is what it is just a class. It is not an abstract class. Okay, it's not an abstract class. So let's create that. So I'm going to say, so I'm going to use small letter square cabin. Okay, and then I'm now going to call it square cabin. And then, of course, in creating that, I have to pass in the number of residents because it is a prerequisite. So let's say it has a resident number of 6. So let's do some print stuff now. First of all, okay. Okay, let's do it. Okay, so okay, so let's do some print stuff now. Okay, so I want to print. So now, just like we've done, you know, where you use objects to access properties and then print. So I want to print the capacity. So I want to know what the capacity of this square cabin is. So I will now I'll use my object, which is the square cabin. So with that object, I can now get the capacity property. Dot capacity. So let me just copy this and then reuse. So the next one, I want to know what building material this one is. So I'll use the object square cabin dot building material. And then finally, let's know if there is room. So has room. I'm going to add a question mark there. I don't need this. So I'll say square cabin, which is the method dot has room. Okay, and of course it's a function, so you have to do this. So let's run this and see what we have. So this is it. Okay, so yeah, we're missing something. So let's see. So we have square cabin, and that is what it is giving us. So okay, so let's work out. Let's solve that problem. So what are we printing? Okay. So I think I did not open. I didn't open this. So just to point out something, you can see this here, square cabin at this young man is actually the object. Remember, the object is also a variable. Okay, this is actually the memory location. Oh, that's just for informational purposes. Okay, so I think we're good to go now. So you can see capacity is what? 5, just like we declared here. We're able to access it. Material is wood. And does it have room? False. Why is it false? If you check, of course, this square cabin is inheriting this function. So the residence that we have is 6, capacity is 5. 6 less than 5 is what? False. Okay. So it's giving us what? False. That means there's no room. If I change this residence to 2, so it's 2 less than 5. What's the value? That's true. Yeah, because 2 is actually less than 5. Okay, so that is actually that. So if you notice, of course, like I just said, this function was not defined in the square cabin class, but it's defined in the house class. But we could, because square cabin is a subclass of the house class, this function has room was now inherited for free. Let me just say that, for free. Okay, so that means this has room function can be called on every instance of square cabin class. Okay, so let's try to see if we could simplify our code. Okay, let's try to do some simplification. Now, in our print line statement here, okay, you notice every time we reference a property or function of the square cabin, notice how we have to repeat this square cabin, square cabin, square cabin. Okay, so it's repetitive. And of course, it can actually be a source of error when you're copying and pasting print statements, just like we had error that time. So we can actually start, we can, so when you're working with specific instance of a class, okay, and you need to access multiple properties and functions of that class, you can actually say, do all these following properties or operations with this instance object, with this object. So we can use a statement called the with statement. We can use a with statement. And how do we do that? We just say with, this is how you do that. And then you just pass in the instance name. That's all. So what am I going to now do here? So what is our instance name? Our instance name, which is our object, is the square cabin. So I'll say with square cabin, that is with this object. With this object, what do I want to do? Print these guys. So I'm just going to, with this object, print yes, print what? Now I don't need to call square cabin again. All I'm just going to call is what? Capacity. So with square cabin, print the capacity. With square cabin, print the building material. With square cabin, print if there is what? Room. Okay, so let's run this and then see the results. Okay, so the result is what the same. So kind of reduces, the number of times we have to call the object. Yes, so that's that. That's that. So this, let me see. Let's see. Let's see. So let's actually just, I'm going to just do one more thing. Oh, I think we have some few minutes. So let's create another class. Okay, another subclass. Okay, and then this subclass, okay, of course, let's see. It's going to be, okay, so permit me, I'm going to just do some, because of time. So I'm going to name this class a round hot. Okay, I'm going to create just like we did the square cabin. Okay, so it's just that this one is going to be straws, and then let's make the capacity 4. Okay, so we can just do this in our main function. We have created it now, already is inheriting the house, so we can get the instance. We can say val round hot, and then give it a default, let's say 3. And then with this, I'll just copy this. And I'm now going to say with round hot. Yes, with this object, print this. So let me change this to round hot. So let's run that and let's see. Yeah, so we have that, the square cabin, and then we have the round hot. Okay, we have the round hot. So yes, so that's actually, so we've just created 2 subclasses. Now, but both of them, they are inheriting the parent class. Both of them are inheriting the what? Parent class, which is the house. Now, but let's create the one of them. Let's create another subclass that will inherit one of these classes here, either the square or the square cabin or the round hot, not directly the base or root class. Okay, so I'm going to call that, so this one, let me just type it. A round tower. Okay. Now, this round tower, of course, residence of type int, which is going to pass, you pass that in. Now, but it's going to, instead of, I don't want it to inherit the house, yet it inherits the round hot. So that means the round hot now is no longer just a subclass of the house, it is now a parent class because something is inheriting from it. It's now both a child class and a parent class at the same time. So post residence. So that is actually that. Now, but let's run this. Now when we run this, you see we have an error. It says this type, what type? It's pointing to this. Say this type is final, so it cannot be inherited from. So what does it mean? This error just means, it means that the round hot class cannot be subclassed or inherited from. That's just what it means. You can't subclass it, you can't inherit it from it. And by default, okay, by default, classes are final by default. Classes are final by default, okay? You can't subclass a class by default. You're only allowed to inherit from abstract classes or classes that have been marked with a keyword called open. So that being said, to be able to inherit from this class, we have to open the class up. Okay, we have to open the class up. So let me give this class some properties of its own. So the tower, so I'm going to use stone, and the capacity, let's say let's just drop down 3. Okay, so with this now, let's run this. We shouldn't have this error again. Good, we don't have the error. So I can now create an instance. of the round tower. So I'm just going to say var round tower, round tower. Let's say a 1. And then just like we did here, with that object, which is what? Round tower, print out capacity and the like. Run this. We have square cabin, round hot, and then we have round tower. So I hope that's actually clear. I hope that's actually very, very clear. So if you have any question, just signify. I think we'll be rounding up shortly. Okay, no question. Okay, so let's move on. Let's move on. I'll just look at one more thing and then just call it a night. So let's see. Let's add something. Let's add something to round tower class. Now, round hot. Okay, let's just look at this. It's a single story building. Okay. Okay, by implication, a round hot is a single story, but a tower can have multiple stories. That is multiple floors, right? Okay, so thinking of the capacity, the more the floor a tower has, the more capacity it should have, of course. Okay, so we can actually modify our round tower to have multiple floors and then adjust its capacity, you understand, to be based on the number of floors. What do I mean? That a round tower will not just have residents, but it should also have the floors. So we're introducing this now. Okay. So this is just an additional parameter, the floors, for the number of floors. Now we just put it after the residents, put a comma, and then so now if you notice, we don't actually need to, we don't need to pass this one. We don't need to pass this to the parents, no. Because the floors is defined here in the round tower. Okay, and then round hot, which is the parent, has no floor. So you don't need to pass it over to this place. Now, just a thing to note, when you have multiple parameters and your class gets too long, okay, you can just do a line break. What do I mean? You can just do something like this. You can actually just do something like this, okay? Especially where you have a lot of properties, you can just do a line break. So, but let's run this code and then let's see. So we have an error. It says no value passed for parameter floors. So yes, we introduced the parameter here, but when we created our objects, okay, we didn't see it here. So it says no value passed for floors. We just pass value for what's the residents. Okay, so we can actually just solve that by giving it a number, but alternatively, okay, in this class definition of the round tower, we can give the floors a default value. Okay, you can give it a default value. Okay, so that then when no value for floors is passed in the constructor, the default value can actually just be used. Okay, so what do I mean? I can just say this is equal to, sorry, this equals 3. Okay, so when we run this code now, you understand, it's fine. Everything is fine. Okay, because it just uses that default value. You don't need to pass in anything. It's using the default value. Okay, so that's that. Now, so let's now update our capacity here for the round tower, because we said that the more floors you have, the more the capacity, right? So that means our capacity now, okay, is going to just be 3 times floors, which is, what is floors? So the number of floors times the capacity. Okay, so 3 times the number of what floors will give you the actual capacity for the round what tower, because it is story the same. So let's run this now. So if we run this, we should, our round tower capacity is now 9. Before now, what was our round tower? Our round tower was capacity of what? 3. But now the floors, because we've given it a default of 3, so 3 times 3 is actually what? 9. So that's the capacity. Okay, so that's actually that. That's actually that. So we're going to stop here for yeah, we're going to stop here for tonight. Okay, we're going to stop here for tonight. So any questions so far? I'm going to stop here for tonight so I can actually sensitize us a bit about a few things. So any questions so far? Yeah, Zed, go ahead.
Okay, thank you very much, Shaikwe. The question I want to ask is this: for abstract classes, do their variables have to be also tagged with the keyword abstract?
Yes. If you don't give it if you don't tag it as abstract, you now have to give it a value. And then if you give it a value, to an extent, you're defeating the purpose of flexibility, the purpose of having another class using that variable the way it wants to use it. Because if you give it a default value, it means that so a typical example is, assuming I say I make this capacity 10, it means that every class that inherits from this house must have a capacity of 10. Okay, so of which it shouldn't be that way. You shouldn't constrain that. So the fact that it should not be, you're not forcing or coercing the classes into using a particular value, you now have to declare it as abstract.
Okay, thank you very much, Shaikwe.
Yeah.
I still have another question.
Yeah, sure, go ahead.
Okay, now, so as to promote flexibility, we have to use the keyword abstract. Now,
yeah,
how about if we, permit me, if we use the keyword abstract, if we use it without the keyword abstract, give it a defined value. If we use override in other subclasses, will we still be able to change the values in other subclasses so it will throw an error?
Okay, so let's do that. Let's do that. I love that question. So let's take this. This is what you mean, right? You're with me, right?
Yes. Yes,
okay,
this is what I mean, exactly.
Yes, exactly. I love that question. That's a very good observation. Okay, so this is what it gives you. So it says capacity in house is final and it cannot be overridden. As far as it has that value, you cannot override it because it has been given a value. So it's just like, remember we talked about, I mentioned something that classes, by default, classes are final. You can't even inherit, you can't inherit from it. Okay, you can't inherit from a class except you open up the class. You have to use the keyword open, but by default, it's final. So the same thing here. Okay, this variable is final. You can't override, because of course you can't override it, it's final. So, but I think if I were you or someone else, I think I would even want to try something. What if I make it a var? You know, we talked about var and val, right?
Yes, mutable and immutable.
So let's try. I like to try out things. So let's try and see. Let's see if it's because it is a val. Okay. So let's run that. So it is not because it is a val. So you can see this even opens up a lot of other stuff. So say capacity has a final var property, public open that is defined, and a lot of whatever. So that's actually just clearly, I think I could have answered, but I'm like, there are certain things when you see it, you understand, you now get to, it validates, some of the answers that we get. So you have to use the abstract keyword, else you cannot override it. Else you can't override it. Okay, yeah, is that okay?
Yes, very okay. Thank you very much, sir.
Yep. Any other question? Rounding up. Okay, so in the absence of questions, so we're going to stop here. And then let's see. Okay. There's still a few things to touch, just a few. I don't know if I can rush it though. I don't know. Okay, so let me just see if I can rush it. Probably 10 minutes time. Okay, because of course you guys will be given another task by Friday. That will actually move it to stage 3. Yes. Okay, so let's do that. So at least I can help to help me to come up with something a bit more interesting for an assignment. Okay, so let's just implement one more thing. So we use that to learn some other stuff. Let's look at the round hot. Let's implement a floor area. How to calculate the area of the floor, stuff like that. Okay, so let's implement that function for a floor area. Now remember, the house does not have that function, but we can just do something quickly. So let's do this. Okay, so I'm going to so let me create a function here. So this one, let me make it an abstract function. Let me just say, so you can draw a function, you can do an abstract function. So now abstract function, and I'm going to say floor area. Okay. And it will return, and this is going to return a double. Now, if you notice, I made this abstract function floor area. Now, why is that? Because the difference between these two is this. Now, because this is an abstract function, it means that whoever is going to inherit from this can calculate the floor area the way that it is peculiar to them. But everybody who is inheriting the has room function, there's only one way to calculate if there's room. Only one way. There's no way you can vary it. Okay, it's going to be resident less than capacity. Except if you have a different way of calculating your capacity, you can just do that to your own. If you have a different way of calculating imputing resident, fine. But this is the standard. But for floor area, it's a bit tricky because, of course, when you have round, now if it's just square, you can just do the whole length times all these length times breadth and all those stuff like that, 2L and the likes. But when you have something that is a bit round, you now have to start looking at radius and the likes. So we cannot capture everything. So you just create an abstract function that a class will override and then use it the way it wants. But that function must return a double. So a double is a data type. Okay. For there's just where you have your decimals, okay, point something and the right, not an integer. Okay, so so this is how we're now going to do it. So to calculate the floor area, okay, of a circular dwelling, it's just pi r squared. That is pi times radius to the power of 2. So of course, pi is actually a mathematical value. So there's a library for that. I think this is where I need to confirm let's see if I have to import that. I hope it works here. Hope it works here. So Kotlin, you won't have to do this in Android Studio. So .math .pi. But if it doesn't work, then we'll just use the default value for pi that we know, which is 3.14. So in the round hot now, let's now implement the floor area. So we'll override it, of course, because it's an abstract. So override function floor area. And of course, this function returns a double. So now we can now implement it the way we want. And how do we want to do that? I want to return pi. I really hope this, okay. Let's see. Let me choose this one. I hope this doesn't, let's see. Okay, but let's just do times. So we need the radius. So I'm going to do this times radius, times radius. But we don't have a radius. Okay, we do not have a radius, of course, because if I run this, okay, it's abstract, does not flow area defined, and blah, 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 blah. So unresolved reference radius. Okay, so needs to work that out. So let's see, how can we resolve that? So I'm just going to, okay, sorry, we're supposed to do this. Let's do this for round, well, it's fine, actually. Fine. It's fine. So I can just solve that by adding another property here, which is radius. And then the radius, so that means when you're creating a round hot, we should also we should know the radius also. That should be a property. So the radius, okay, so that suffices for this. So we use this radius to calculate. Yeah, so let's see. Okay, so I think that radius should go out. Okay, still, or did I not spell it well? Okay, sorry. Yeah. Okay, so no value passed for parameter. Okay, so I think that error is somewhere here. Yes, we need to pass in a radius property. Okay, we need to pass in a radius property. That's one. So let's look at all the places we have errors here. No value passed. The next place we have an error is here, square cabin. Now, let's see. Class square cabin is not abstract. It does not implement this floor area. So we have this error that this guy is not implementing the floor area. So we're going to have to work that out quickly. Okay, so let's see. But before that, okay, remove field. I think probably I'll just take that. So we'll have to do it. So let's do this because you have to override that. So just override it for all of them. Override it for all of them. But so let's just, for now, let's just use, you can actually, this import statement will work when you're using an actual monitor, or probably there's another playground, but I don't know if this will work here. So for now, let's just use the actual value of pi, which is 3.14. So now the fact that we have created this abstract function here, it means that these guys also have to inherit it also. That's why you have some of these errors here. So so I'm just going to copy this one. So for a square cabin, a square cabin does not use radius. Okay, so for the square cabin, it's just a length. So just going to add length of type double. And how do you calculate the floor area? It's just for square, it's just length times length. Okay, round hot. Okay, we need that. So then for the round tower, also the round tower is, since it's going to the round tower is going to, so for the round tower, now we're going to use we have floors. Okay, we need to add a radius also, a radius property. So radius radius of type double. Yeah. Okay, so now to calculate the floor area, okay, so what we're going to return is so now this is very interesting. This is very interesting. Now I can now, instead of doing that whole calculation, okay, instead of doing that whole calculation, I can actually just do something. I can update the floor area. Now, this is what I mean. This guy, the round hot already has a calculation for this. He already has a calculation for floor area. So, and since round tower is inheriting from it, okay, I can just say to calculate floor area for this round tower, okay, I can just say something like, well, let me just do the normal one first. Let me do the normal one first before that. So after this, we also need to multiply by floors. Of course, for the round tower, you need to also multiply it by the number of floors that you have, okay? So let's run this and check that everything is okay. So no parameter passed for length, where, okay, so we need to, first of all, okay, here. So square cabin still has, so square cabin has length, so we need to pass in a length parameter. So let's say, let's assume that the length is 20.0. The round hot needs a radius, so let's say a radius of 3.0, and then the round tower also needs a radius, let's say 2. Sorry. And then this is, let's say 2.5 for the radius. Okay. What else? So var open property. Okay, I didn't change this back to var. Okay. Okay, so let's see if we have any errors. Okay, next one. So the floating point does not conform to the expected type int. Okay, so let's see. Okay, so round tower needs two things. Residence int radius double. Residence int, okay. Yeah, I think we're, yeah. Okay, so let's see. Let's go higher, but thing. No value passed for parameter radius, where radius hides member of supertype. Okay, so let's run this and then confirm. Okay, so let's see. So this radius of type double, okay. So it's saying that the floating point, what? Okay, let's see. No value passed for the radius. Okay, radius is here. Okay. Okay. So let's give, okay, floors is 3. Okay, so this takes 3 things. Sorry, it takes 3 things. Resident, floors, okay, and then that. But yeah, we made it default. So let's do something. Okay. Yeah, thank you. So we don't need to create a variable. No, don't need to. This we don't need to. And then this round hot. Remember, this we are extending this class. We are inheriting from this, and this has radius. So we need to, yeah, skip that. Yes. Yeah, so I think so let's confirm. This is called, so all this process is called debugging, where you get to find out what exactly is wrong with your code. So here, the floating point, okay, no parameter passed for radius. So our round tower class, let's see, it takes three things, the residence, so let's do something. Okay, the radius and then the floors. Okay. Okay, and then we have our building material and then, okay. So radius, floors, okay. And then here one, okay. So let's see. Yeah. Okay, yeah. So that works. That works. Yeah, so that works. So it runs perfectly. Okay, so but one of the things that what I wanted to do, I wanted to just go straight into, instead of having to start, because if you notice this, if you look at this, the whole of this is the same as this. So instead of rewriting this again, okay, instead of repeating the code, I could just say this, return super. Now when I super dot floor area. So what does that mean? Okay, all I'm just saying is update, in the round tower class, update the floor area to use the super class implementation. You understand? So use the super. So with this word super, I am now referring to the round hot. That is the floor area value of the round hot. Okay, that's just to make your code to avoid repetition of code. Okay, so I think at this point, yes, this I should round up. There is just a little, just one thing left now. Should I finish it up? Or okay, maybe we can have, if we are chanced, maybe okay, in our next class we can actually have, maybe if we can have a 30-minute session, probably tomorrow or Friday, then we'll just finish maybe tomorrow. Okay, I'll find time tomorrow, even if it's just 9 to 9:30 or something. We'll talk about that. Just finish up. It's just a few things left, but because we have a lot of KodeCamp has other engagements to do from 9 p.m. that I have to be in attendance. So this is where we'll draw the curtain. So we'll talk on the channel, see if we can fix a time to just finish this up before your task is dropped. Okay, so any question before I round up? Okay, so no question. Okay, so that's fine. Okay, so guys, thank you very much. Okay, the video is available on YouTube. You can rewatch and get yourself remind yourself of what we have actually learned today. Okay, so thank you guys very much. So we'll see you on the workspace. Yeah, so I think thank you so much.
Thank you, sir.
Yes.
Thank you, sir. Thank you, sir.